Hello and welcome to the course of HDL Digital Circuit Design. In today's session, we'll be seeing how to write a test bench for 16 by 4 RAM. In previous lecture, we have seen how to write a Verilog code for 16:4 RAM and concept of implementing 16 by 4 RAM. So myself Shilpa Rutrawar, Assistant Professor, School of ENTC Engineering, MIT Academy of Engineering, Anandi, Pune. So for the concept of 16 by 4 RAM and its Verilog code, you can go through the description box where the link of previous video of implementing it on Verilog is I'll be putting. So test bench, how to write it for 16 by 4 RAM, that will be explained in this particular session. So this we have seen what is 16 by 4 RAM, what are the inputs output available, how many memory locations will be there, how much data you'll be putting inside each location. This is the code we have seen previously, and this is the waveform we'll be able to see once we are writing a test bench. So in this session we'll be seeing how to write a test bench for 16 by 4 RAM. Now as we have seen over here, we are having address as an input, data in as again an input, and clock and write enable, these are the inputs. Only this data out is the output, and in the test bench what we'll be doing, we'll be writing a code for generating this input, that is the soft input. So over here you are able to see this code where first we need to generate a clock. And how to generate a clock? Just by providing a initial block, and inside that we'll be generating a clock. So clock is 1 at start, so this is clock is 1. You are able to see how, if you are writing a code in this way, how you'll be getting the simulation waveform. So clock is 1 at start, and then the clock equal to not of clock after every time scale, and it will be happening forever. And that's why previously it was 1, after 10 time scale it will be 0, again it will be 1, again it will be 0. This will be happening forever, as we have written forever over here. So this is the initial block for generating the clock signal. Once that has been generated, you need to write a test bench for generating write enable, address and data in. So initial block has been written, begin, end of that block. Now we need to give input as a, because in RAM we will be performing writing as well as reading operation, and first we'll be writing the data in that particular location, and that's why we need to provide the location. So here address is the location. So what it has been given 10, so I'll be giving address as a 10 because total 16 locations are there, and I'll be providing out of that, that is the 10th location. And inside that I'll be putting, or I want to write a data like a data underscore in 4-bit hex number, that is A. You can write 4-bit binary number as per your format you can give. Here I have given in this way. It is not mandatory to provide the data in this way only. You can change the format. So over here 4-bit hexa number, that is A is present. So I'll be putting A at that location, and for that I need to perform the writing operation, and that's why writing is possible by making write underscore enable 1. So write underscore enable is 1, address is 10, and data in is 4-bit, that is A, and we'll be doing this operation for 40 time scale. So here the data is that delay is provided, that is the 40 time scale. So what is the meaning of this sentence? That when the clock is positive edge trigger and enable write underscore enable is 1, so write underscore enable is 1, address is 10, over there data will be present, or data will be written as a 10, and that's why you're able to see this. Same way, how many locations you want to give, and as per that what data you need to put, you can give in the same way. So I just copy pasted this particular part, and I have changed the address as a 9 and stored the value 9 in that 9th address. Same way you can give anything. You can change the location, you can change the data. So only 4 locations I have mentioned, and inside that 4 location I have stored the data. So 10th location data is 10, 9th location data is 9, 8th location data is 8, 7th location data is 7. Okay, so you are able to see 10th location data is A, 9th data is 9, 8th it is 8, and in 7th location data is 7. Now over here you are able to see, now the writing operation has been performed. I need to check what is present, what is the data present in that location. So I need to read the data. So as I have stored that particular data over there, so same data I should be getting at data out, and that's why First thing is that write underscore enable you need to make 0, because whenever it is 1 you'll be able to write the data, and whenever it is 0 you need to read the data, and that's why for reading purpose you need to make this write underscore enable 0. Now which data you want to read, so you need to give the address, and that's why address has been given. So that address is address equal to 10. So at 10th location, what is the data we have stored previously? That is the 10, that is A. So we should be getting A at data out. So just check, when data write underscore enable is 0 and address is 1000, you will be able to see data. Wait a minute. You will be able to see the data as this 1010. Again, because of some issue, I am not able to show it over here. So I'll be putting that particular part here. So you are able to see that at 10th location the data is 10. Again at 9th location I am giving address as a 9 and I want to read the data. So at 9th location I am getting data as a 9, because this is data out. You will be getting, because of this you will be getting output over here. So 8th location, as you have kept 8, so you will be getting 8, and at 7th location you will be getting 7. So first put the data, perform the writing operation, and then perform the reading operation, so that whatever data you have kept, same you are getting or not, that you can verify. And in this way we have written a test bench. So hope this part is clear. You can modify this test bench by providing different data and multiple addresses, because I have given only 4 addresses and 4 data has been stored at the 4th location, but you can store 16th location over there. You can store 16 data, that is 4-bit data at 16 locations. So according to that you should be able to modify your test bench. So hope this part is clear, how to write a code for 16/4 RAM, how to change it if that has been asked, that you need to perform 8/4 RAM. So 8 location will be there, and inside each location you will be storing 4 bit of data. So that should be modified as per requirements. So only the things you need to be changing over here, that this one. So this is what is the 4-bit data you are storing in each location, and there are such 16 location. Same way 4-bit data, that's why this is of 3:0, and address, because of 16 location, address is 3:0. So according to that problem statement you should be able to modify these things. So hope this part is clear and you have seen how to write a test bench as well as the Verilog code for 16/4 RAM. So thank you everyone.